When visual inertial odometry is combined with a single UWB device per agent, the relative pose between agents can become observable through relative motion. However, there are situations where the relative pose between the agents is unobservable. Intuitively, one can see that when both agents are not moving, the possible relative pose of the estimated agent is on a sphere around the estimating agent. Other modes of motion that lead to unobservable relative poses are shown here. The trajectory of the estimating agent and estimated agent are shown in blue and orange, respectively. The yellow agents represent indistinguishable trajectories from the true trajectory. To estimate all possible 3D solutions when this relative pose is unobservable, an unscented particle filter with a pseudostate for drift correction is proposed. 48 particles represent the initial relative pose of Agent 1, shown in green. The real pose of Agent 1 is shown in black, while the pose of Agent 0 is shown in red. At first no motion exists between the agents and hence all particles remain. After some time, Agent 0 starts to move and as is shown multiple particles are moving towards the more likely solution, while others are killed. Finally, when Agent 1 starts to move, more particles start to deviate from each other. Many get killed until finally the most likely particles remain. The algorithm was tested in simulation, as well as experiments. During the experiments the agents were driving to randomized targets for 5 minutes. The average error in the position and orientation in function of time are shown on the left and right plot, respectively. The proposed algorithm, in green, was compared to an algebraic, NLS, and QCQP, implementation in orange, purple, and blue, respectively. The NLS got the true initial relative pose as initial guess, since it cannot find the initial relative pose as opposed to the other algorithms. Additionally, the algorithm without pseudostate is shown in red. For both errors, the proposed algorithm converged to a more accurate solution than the other algorithms. During a 60-second period, Agent 0 was stationary to test 2 unobservable motion scenarios. The estimations of Agent 0, in lively blue, all converged to the actual pose in dark blue, while the others were eliminated. The 4 remaining particles cover the initial orientation distribution. Similarly, 4 remaining estimations of Agent 1, shown in red, spread around Agent 0 in a circle. These represent the distribution of the initial azimuth. It is to note that the azimuth uncertainty of each of these particles stay around 0.5 radians, while the azimuth uncertainty for Agent 0 drop below 0.1 radians.